hit the target. I made a small game using your trigonometry. So the basic idea here is you're on the surface of the earth. You have a target that you have to hit. Okay. So your launch pad is over here, right? This is where you're launching from. Okay. So you launch from here, and since it's near the surface of the earth, it will be influenced by the gravity of the earth. Okay. So the effect will look like as if it's being pulled down. So you have to launch it in a way wherein it will take this motion, projectile motion. Okay, this is known as projectile, and hit it. So how is it a game? Well, I have given you the control of the speed and the angle at which you launch. Okay, so you're looking at this initial speed, u, wherein say it can be 100 meter per second or kilometer per hour, whatever that, and also the angle at which you launch. Okay, I've given this flexibility. So basically, you will be able to input the speed and angle. This is all you have. Everything else is out of your hand. Gravitation of Earth, not in your hand. Wind speed, not in your hand. And not simulated wind speed. You can do that. People who are interested, you guys can do that. It's not a hardcore coding. It's a simple coding. If you know the physics about it, it's not that hardcore. Okay. So let me show what I've done. It's a very simple program. So here I've seen, here you can see I've simulated few times. So you get to enter the initial speed and the initial angle in degrees. Okay. So let's do that. So here I've used a library called as Turtle. So I'm simulating, this is your launch pad and this is your target. So I'll have an initial speed of say 100 and let us launch at an angle of 60 degree. And oh, we just missed it. Okay. So let's try it again. So let's recalibrate. Okay. Now things are ready to launch. So let's go with 100 itself. Let's reduce the angle. I think 50 will help. Oh, wait. It went far away. That's weird, right? The reason is the physics. Okay. That you'll understand in different grade. So let's again simulate. So I can't do that. I'll keep 60 angle, but I'll reduce the speed. So let me make it as 90. So let me make the angle as 60. Will I hit it? I missed it again. I think 95 will help. So let me make the speed 95 and angle 60. Finger crossed, and we hit the target, right? So you can ask your friend, okay, I'll fix the speed. You have to decide on the angle. So number of chance they can take, and you can, again, you guys are good at making games, so you can make a game out of it, right? So other than that, you have an option of changing, looking at, if the same thing is launched on the surface of the moon, what will happen? To do that, what you guys can do is just change the acceleration due to gravity here. Okay. This value you guys change. Make it 10 by 6. So 1/6 of the acceleration due to gravity on the surface of the earth is the acceleration due to gravity on the surface of the moon. Okay. So just make it 1/6 and see how it behaves. And again, you can decide on the speed and angle, and you can make it fun. So you can make it on the surface of the moon. You just have to web search what is the acceleration due to gravity on the surface of the moon. Change this 10 value to whatever you guys want. Okay. So the program will take care of everything else. Right. Now, coming to where is the math of it? The math is over here. Right. The trigonometry part is over there. So let's analyze this. So what is that exactly we are doing over here? See, projectile motion is a two-dimension motion. That is, it will move vertically and horizontally. That's why it's able to, it's basically moving in 2 dimensions, is it not? Vertical and horizontal. So the thing is, when you launch something, you can talk about its vertical speed and horizontal speed. So this is your vertical speed, sorry, horizontal speed, and this is your vertical speed. So horizontal speed is the opposite side of angle theta, and vertical speed is, sorry, no, I told wrong. This is adjacent, and vertical speed is opposite. Make sense? Right? Just a right angle triangle, nothing else. We know the hypotenuse, which is 100. We'll just call it as u. So we know, okay, now we are looking at a triangle wherein we know the hypotenuse. We have to find the opposite and adjacent, and we know the angle. So we have to link an angle with other sides. So what topic will help? Trigonometry, is it not? So what part of trigonometry, what part of trigonometric ratio will help? Well, I want adjacent first. I know the hypotenuse. One of the trigonometric ratio which links is cos. Cos is equal to adjacent by hypotenuse. So adjacent we have to find. Hypotenuse we know. If I cross multiply, adjacent is equal to cos theta into u. Is it not? Right? Next, sine theta is opposite by hypotenuse. So what is opposite? We don't know. We know hypotenuse though. So opposite by hypotenuse is u. So opposite is equal to sine theta into u. Right? We got our hypotenuse, we got our opposite and adjacent values by knowing the angle and the hypotenuse. Right? This is what we have done over here. See here in the programming, I have written velocity along the horizontal is u cos of theta. Forget about this math dot. No, that you'll understand it's not that big deal. Okay, so this math dot also you forget. So it's a product of initial velocity into cos theta, the horizontal velocity, and the vertical velocity is initial velocity into sine theta, and that's what we got over here. Right? See, it's not that difficult. At least Newtonian physics, whatever we use day to day, it's not that complicated physics. When you talk about quantum physics, it's difficult. There's a lot of things. It's like I'm being honest, I don't understand a lot of it. I'm not trying to understand till now, to be frank. Maybe in time I'll study about it. I want to study about it, to be frank. But yes, whatever you study in your day-to-day engineering or physics, right? It's not that hard, at least till your degree. Post that, yes, you'll have really good physics, which will be the latest. And all this is well established and it's been used for quite some time. So it's very simple. Don't get scared. Please learn the topic. It's not at all tough. Okay. Have fun.